Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hanafi Adli bin Ahmad Sobri and my metric number is CE190071 and today I will be presenting for my final year project with the title is BLDC Motor Speed Control based on PID-FUZZY controller. As for introduction, in this era, technology is very important. Within technology, humans can improve their life, meaning that they can generate income through technology. Technology also can help humans solving their problem. A new technology, it can help to increase the industry performance in order to fulfill all the requirements from the consumer. There are many applications with motor as the main equipment for their model and product, especially BLDC motor. This is why I choose to improve BLDC motor performance for my final year projects. BLDC motor can offer many advantages and benefits. It also used in many applications and also chosen by industry. From the literature review that I have made, I found out this controller that will be used to control the speed of BLDC motor. The first one is the PID controller, which is it can operate well and yield better traction response. It is simple, robust, reliable, and easy for the consumer to use it. The second one is the fuzzy logic controller. Fuzzy logic controller have many advantages such as to reduce the computational time and it also can deal with non-linearity. And the last one is the PI controller. PI controller cannot operate well in various loading conditions and it has poor performance compared to the PID controller. For the problem statement, usually BLDC motor used in a linear application have no problem with the controller used to control motor speed. For your information, linear application is an application that cannot involve load variation or disturbance. In reality, a brushless direct current or BLDC motor is a non-linear motor because it is extremely sensitive to load disturbance and parameter variation which have the potentially to modify the speed away from the constant speed that has been established by the user. That is why the controller is very important in BLDC motor operation. For the objective, I have three objectives for this project. The first one is to simulate and model the BLDC motor. The second one is to create a proper speed controller using the PID-FUZZY method. And the last one is to check the effectiveness of the proposed method by using simulation by MATLAB and Simulink. Next, for the methodology, we start with the project flow. Based on the flowchart, the first one, we establish a project objective for the initial step of this project, and then we performing the research and study the previous work. After that, we'll be develop and design the PID controller, and after that, we run the simulation. If the simulation is a succeed, we'll be compare the outcome or the result of the of using the PID and PID-FUZZY controller, and we'll be do the analysis. Meanwhile, if the simulation is a fail, we need to do a correction for the modeling to correct it. Next, BLDC motor was invented by T.J. Wilson and P.H. Rickey in 1962, but BLDC motor only available in 1980 because permanent magnet only available at that time. The table beside show the parameter of the BLDC motor that used in this project. The block diagram below show the component. It consists of the BLDC motor, voltage source inverter, speed controller, half effect sensor, and commutation block. A voltage source inverter powers the BLDC motor. Then the signal for the firing the power semiconductor device in the voltage source inverter produced from the commutation block. The Hall effect sensor monitor the rotor position and operate as position sensor. Based on the Hall effect signal, the commutation logic block will create EMF. From the EMF, the commutation block will produce the gate signal. Next, moving for the PID controller. PID controller is the combination of the proportional gain, integral gain, and derivative gain. PID can increase the steady state response and the transient response. PID can work very well in the condition parameter not chain or linear system. PID controller have many methods to tune PID parameter. The one I use in this project is using Ziegler-Nichols ZN technique. There are other methods that can be used to tune the PID with using the Simulink PID tuner. Next is the PID-FUZZY controller. So fuzzy logic is a control method based on linguistic control strategy derived from the expert knowledge, which will be transformed into an automatic control strategy. Fuzzification is the process that transforms the input called crisp value into the fuzzy linguistic variable. Besides is the fuzzy logic structure, is consists of the rules, fuzzifier, intelligent, and defuzzier. Defuzzification is when all the actions that have been active are combined and tuned into a single non-fuzzy output signal, which is the control signal of the system. The rules based in the are in the form of the if-then statement. The rules are generated from the rule base and were computed by using interface engine. For PID fuzzy controller, this study will merge the fuzzy logic controller with the PID controller. This type of controller can be categorized as a hybrid controller. Below is the mathematical equation for the PID fuzzy controller. This KP1, KI1, KD1 is the output of the fuzzy logic. For the KP, KI, KD is the value of the PID parameter from the conventional PID controller. From the picture, it shows the connection in the PID fuzzy controller created from the mathematical equation. Next is for the result. The simulation result for both PID and the fuzzy PID fuzzy controller. Firstly, the constant speed simulation testing is observed. Secondly, both systems are tested under load disturbance operating condition. And lastly, the sudden load 0.2 nm is applied at the time 30 seconds under load disturbance condition. The first table, the first graph is show the result for constant speed when the reference speed is 3000 rpm, and the graph beside is the result for the constant speed when the reference speed is 1500 rpm, and this graph is for the reference speed in 1000 rpm, and lastly for no load testing is when the reference speed is 500 rpm. After that, we test the project using this load disturbance. So this first graph show the result for load disturbance when the reference speed is 3000 rpm. And the next graph show the 1500 rpm. And for this graph is the result for load disturbance when reference speed at 1000 rpm. And the last one is when load disturbance when the reference speed at 500 rpm. For conclusion, this project demonstrates two types of controller that used for the speed control in BLDC motor application. The first controller is PID controller and the second controller is PID fuzzy controller that has been proposed in this project. Based on the result, the PID-FUZZY controller showed a good disturbance rejection capability compared to the PID controller. The actual motor speed more accurate followed the reference speed. By using the same testing condition, the PID-FUZZY controller has better performance when the load applied or no load applied to the BLDC motor compared to the PID controller. Okay, that's all from me. Thank you.